we need to express this really small number in scientific notation. Let's just see how small it is. It is 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros, and then a 3, 4, 5, 7. And all of that is behind the decimal point. Now, just as a bit of review about scientific notation, it means expressing a number in a form where it's going to be some number. I'll just give an example. It could be, say, 5 times 10 to the fifth power. This would be an example of writing something in scientific notation. And when you write something in scientific notation, the number that you're multiplying by a power of 10, that number right there has to be greater than or equal to 1, and it should be less than 10. And of course, this right here is going to be a power of 10. So for example, if I were to write 5 times 9 to the fifth, not scientific notation. If I were to write 50 times 10 to the fifth, not quite scientific notation. Sometimes this kind of gets by for scientific notation while you're doing computation. But if you really wanted to write this in scientific notation, you would write this as 5 times 10, which is 50, times 10 to the fifth. And 10 times 10 to the fifth is 10 to the sixth. So you'd write this as 5 times 10 to the sixth. So your goal is always for this number right here to be greater than or equal to 1, less than 10. Likewise, if I wrote 0.9 times 10 squared, once again, not in scientific notation. You would want to write 0.9 as 9 times 10 to the negative 1 times 10 squared. And then this becomes 9 times 10, which makes sense because 0.9 times 100 is 90. 9 times 10 is 100. We can say 9 times 10 to the first power. So that was a bit of review. Let's do it for this problem right here. So in order, I guess a quick way to think about converting this to scientific notation, think about how many leading zeros there are, including the first non-zero number right there. So there are 10 digits to the right if you include this 3. You have 9 zeros, and then you have this 3. So a very quick way to do it, and I'll explain in a second why it works, is we could rewrite this right here as 3.457 times 10 to the, and remember, we had 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I count the 3, 10. So times 10 to the negative 10 power. And the reason why this makes sense is when you multiply something to a negative power, you shift the decimal over to the left. So you're going to have to shift this is essentially saying, let me write it this way. Start with 3.457. Start with 3.457. And when you multiply it times 10 to the negative 10, you're going to shift the decimal to the left 10 spaces. So if you shift the decimal to the left 10 spaces, what do you get? So if you shift it once, twice, 3, 4, 5, 6, 7, 8, 9, 10. And of course, you can't just leave open space here. There's going to be zeros there when you shift it. So you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. And you can put a 0 out here just to make sure that you understand that this is there's a 0 in front of that decimal. And you get exactly what we got up there. Another way to think about it is if you wanted to start with this really small number, and you wanted to get to 3.457, you could multiply it by 10 to the 10th, right? That would shift this decimal 10 spaces to the right. So you could do this. You could say that and these are all the multiple ways of looking at the exact same thing. You could write that 3.457 is equal to this character, or I could even copy and paste this character, is equal to this guy. Let me copy and paste it. Copy and paste is equal to that guy times 10 to the 10th power, right? If you multiply by a positive exponent, you're multiplying by 10. Every time you multiply by 10, it shifts the decimal to the right. It makes the number bigger. So if you multiply this by 10 to the 10th, this guy's going to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It would shift it right there, and you'd get 3.457. So that's the whole idea. That's 3.457 is this number times 10 to the 10th. So if you wanted to solve for this number, you would multiply both sides of this equation by 10 to the negative 10. So times 10 to the negative 10, or that's the equivalent of dividing by 10 to the 10th. So 10 to the negative 10th times that right there. These cancel out. 10 to the 10th times 10 to the negative 10th is 10 to the 0, or just 1. 10 to the 0th power is just 1. And you get this thing over here being equal to 3.457 times 10 to the negative 10. I just wrote it in a different order over here.